Now, I am done giving you the terms of wave equation. Those terms I gave, like I said initially, are the precise terms you need to derive equation of motion and understand it better. So now let's talk about equation one. Equation one, we have y is equals to a sine bracket wt minus phase angle. This is equation one. Now what does this thing mean? Y is equals to a sine bracket. What is this w? 2 pi f, then the t there, minus kx, right? Now, y is equals to a sine bracket 2 pi ft minus, you understand? Remember what our k was? Remember I told you that our k, let me write it somewhere here, tiny. Our k here is equals to, that is ks. I said ks here is equals to 2 pi x over lambda. Don't forget. So here we are going to write what? 2 pi x over lambda, right? So this is equation 2 already, but if you factor it out, now we're going to have y is equals to a bracket, y is equal to a sine, oh, I want to factor out, the common factor here is 2 pi. Y is equals to 2 pi bracket ft minus x over lambda. Call this equation 2. Now for our equation 3, how do we get our equation 3? Don't forget that f, I told you something about v, equals to f lambda, right? And f from here is equal to v over lambda. True or false? True. So anywhere I see f, I substitute this. I'll use v here. You understand? So y is equals to a sine bracket 2 pi ft. I'm repeating this equation 2 now, minus 2 pi x over lambda, right? Now to get my equation 3, this is y is equal to a sine bracket 2 pi. Now where there is f, I will replace it with v over lambda. So I will have v over lambda t minus 2 pi x over lambda. So what do I do then? Over there, the common factor here is 2 pi, right? 2 pi over lambda. Common factor here is what? 2 pi over lambda. So what do I do then? Over here, y is equal to a sine 2 pi over lambda bracket. Do I really need this line? No. 2 pi over lambda then bracket vt minus x, call this equation 3. How? 2 pi over lambda times vt, look at it here. 2 pi over lambda times vt is equals to 2 pi vt over lambda, just as we had it here. For that, this for this. Now, for that, 2 pi over lambda times minus x, we are going to have minus 2 pi x over lambda, just as we had it here. Do you get? That is that for equation 3. Now let's talk about equation 4. Let's talk about equation 4. For equation 4, eh, now it's something totally what? Different. Remember in equation 4, I told you something about t being that is I made mention of t equals to lambda over v, right? True or false? And I equally said that if you make lambda subject of formula, it becomes lambda equals to tv. Is that correct?
Yeah.
Is that correct? Good. So I'm going to apply this here in equation 4. And there are two things I can use to get my equation 4. Is either I use this or I use this particular one. W equals to 2 pi f, which is equal to, this your knowledge, which is equals to 2 pi v over lambda, and this is also equal to what? 2 pi over capital letter T. So I can use either this or that. So let me first of all use this to show you equation 4 over there. Then use the second one to show you equation 4 somewhere here. Do you get? Now, equation 4. For equation 4, I need to clean these things that I wrote here. Okay, let me just start from here. Let me point this arrow to equation 4. Now look up. Equation 4 now. From equation 3, I have that y is equal to a sine bracket 2 pi vt over lambda minus 2 pi x over lambda, right? Now, I want to use this for my equation 4, which means lambda here is equal to tv, right? Lambda here is equal to tv. So I'm going to say y is equal to a sine bracket 2 pi vt over tv, right? Minus 2 pi x over lambda, right? This over lambda, this v will cancel out here. So we're going to have y is equals to a sine bracket 2 pi t over t minus 2 pi x over lambda, over what? Lambda, right? But in this case, have you seen that here is t over t and here is 2 pi? The common factor here now is 2 pi, right? So y is equal to a sine 2 pi bracket t over capital letter T minus x over lambda. Call this equation 4. Using this one. Do you get? Now let me use this second one to still get equation 4. In that case, I have to shift this somewhere here. This thing I wrote here, 2 pi over lambda times minus s, which is equals to minus 2 pi x over lambda. I have to clean this. Right? I have to clean this so that we'll see it clearly. So from here, now from this one, let me draw my line pointing here. Let me draw my line up here. See where it's going right now. Using this one now to still get equation 4. So now, from equation 3, y is equal to a sine bracket 2 pi vt over lambda minus 2 pi x over lambda. What do you do then? Remember that 2 pi f v 2 pi f is equal to 2 pi v. Don't forget that the origin of this place is wt, and the origin of w is 2 pi f, which is this, right? Now, using this thing now means that anywhere here now, that means for me to clear you on this, let me just give you back equation 1. Let me remind you that equation 1 is a sine wt minus phase angle, and is also what? And this wt is also a sine 2 pi ft minus kx. This is equation 1. I want to remind you about that so that you won't be confused on what I'm going to do over here. So now 2 pi over lambda is also equal to 2 pi over t. So here y is equal to a sine bracket 2 pi v. That is this 2 pi v times t here over lambda over 1 minus 2 pi x over lambda. So this 2 pi v here means y equal to a sine bracket y equal to a sine bracket 2 pi over t times t over 1 minus 2 pi x over lambda, right? Which gives y equal to a sine 2 pi t over capital letter T minus 2 pi x over lambda. Why the final equation, the same thing with what we have here, y equal to a sine 2 pi being the common factor over there, t over capital letter T minus x over lambda. Call this equation 4. So are you seeing that with this we are able to get, with this one we got this, and with this one we got something like this. Did you understand now? So you choose the one that suits you best, right? If this, use it and get this. For this one, using this one now, you use this one to get the one over there. Did you understand? Use this one to get the one over there. So that is that for if we had to derive equation 1, equation 2, and equation 3. So for you to understand the terms applied here, what do you do? For you to understand the terms applied here, what do? You watch the next video. Now, this thing now might look confusing to you, but let me just state something here. Let me make it in a way that it will appear a kind of I want to do something now. Just exercise patience with me. I'm not changing anything from what we solved. I believe you've seen all this, right? Good. You've seen all these things, right? Good. Now, I want to do something that will enable you understand it clearly. Now, for this, we use this. Now, for this, make use of the W equal to 2 pi f, which is equal to 2 pi v over lambda, which is equal to 2 pi over t. This is whole of that. And this one is for this. So it is easier that way. Equation 3, equation 4. So thanks for watching, and give this video a thumbs up. Don't forget to subscribe and share the link. Thanks.